Hey guys, starting with this video, I intend to share my knowledge and my experience on test automation and all the things that I've learned around test automation with you guys. Now, why do I want to do this? Well, I have learned a lot from internet, from testing community, by reading books and by working on the projects with some of the very awesome, talented people. And I think it's my turn to give it back to the community. Who is this video targeted towards? So I am focusing to target towards young testers, like who are just starting their career, so that they can learn how to do things right. But it's not only limited to them. I'm pretty sure there could always be a thing or two that maybe like some of the media testers or some of the senior testers could learn from these videos. And of course, I'm pretty sure there must be a thing or two that you might can suggest me on how it can be done better, in which case I will put this project on GitHub. So feel free to create a pull request and either like contribute directly or give me some suggestions in which we can improve it together. Now, how are we going to do this? So I plan to take this problem into two parts. First, I would like to give a big picture of how the whole end-to-end test automation process looks like, and this is what we will cover in this very first video. And that is also the reason why I think this is going to be a little bit longer video, maybe around 20-25 minutes, hopefully not longer than that. And after this like big overview is done, then probably I will create shorter videos of maybe, I don't know, 5 to 10 minutes, in which we will try to target one topic at a time, so that we can keep it focused and we can learn more good things about it. I have not yet created the whole checklist, but I am assuming it might be at least 20 to 25 videos that should be able to cover the whole end-to-end thing. Once we start working on it, let's see how good or bad this prediction is. So without any further delays, let's first look at the big picture first. And the reason why I want to give you a big picture first is, once you understand how everything fits together in the whole end-to-end test automation process, you will be able to understand, when you will learn about a certain thing, that where does it fits into the whole process. So for example, you will see where the test framework fits into the big picture. You can see where the CI comes into the big picture. You can see where do we build our applications. You can see how we can keep our framework more flexible, so that it can run into different test environments, and that is something that, for example, we will cover using configuration. Then you can learn about, for example, different modes of execution. You can learn about how to randomize your test data. You can learn about how to publish your test runs on end-to-end monitoring system, something like Elastic and Kibana. You can see how to, for example, create test reports, how you can integrate the whole process with Slack, so that you can get notified when your test runs are finished. And also in the end, once the whole automated process ends, we will also see, for example, what is the manual intervention part, where you have to do some analysis and you have to do some fixes, either in your code or in the application where you log some bugs. So this is the whole end-to-end process, which we will cover pretty much in detail in this video. So let's do one thing. Let's first look at some of the legends, so that we can understand how to read this particular workflow. So what you will see in this diagram is, I have used some thick arrows and I use some thin arrows. And what it means is, even though both of these things will be available to the user, but if I am marking something as thick, then I'm telling you that this is more of a preferred way of doing that particular thing. And the thin arrow is more like, well, you can do it, but I'm not recommending you to do that, because it's not more practical way of doing it, right? In this case, for example, the other two icons is about a test automation, like naming your test automation framework. I like to name my test automation frameworks with single words. So in this case, for this example, Hulk is the name of the test automation framework that we're going to use as an example in this particular workflow. And then of course your application need to have a name. So in this case I'm just picking a random application, which is Spotify. So this was about the legend. If you look, for example, in the workflow, you will see we have two different workflows here. We have a workflow in the remote mode and we have a workflow in the local mode. And the reason why we have these two workflows is because we have two very specific use cases, one for remote and one for the local mode. So as a test automation engineer, you will be like creating new tests, you will be maintaining broken tests, and that's a part which you'll be doing most of the time in your local machine on a local mode. But once your tests are stable, once they are working correctly, then you basically want to run them into CI. You might want to run them on the stable branch of the application, or you might want to run them with the pull request of the application. Does not matter, but all that running stuff happens in the CI, right? So let's go to our first step, and in the sense, what do we do like first in remote, and what do we do first in the local machine? So when you want to trigger your test in remote, you basically have three different use cases, like why you would want to trigger your test in different ways. So let's take the use case number one. So this is the case where, let's say, you're trying to add new test, or you're trying to fix broken test, and you want to create a pull request on your own test framework, right? And you want to run like those new tests on a branch with the stable version of your application, and you want to make sure, and the reason why you want to do this is because you want to make sure that your new tests are not breaking anything existing in your test framework, right? So that's like one use case. And of course you can also trigger a build manually from your test automation framework. So it's possible, but like I mentioned here, it's possible, but that's not what we will commonly use. So that's what this arrow shows. The second use case that you can see is, so imagine let's say with your application, maybe your developers create a pull request, and the pull request is merged into the main branch. It could be the main branch, or it could be the stable develop branch, and then you want to run your test immediately after that code is merged into that into the develop branch of your application code. And that the reason, or like the use cases where you want to do that is, so let's say if you are testing a mobile application, or if you're testing a browser application, so typically the browser the browser test and the mobile test, they're a little bit slower in comparison to, let's say, API test, and there's also a chance of getting them more flaky, and no matter how much you try to make them more stable, because there are so many moving parts, which makes like those kind of automation feasible, it's always possible that something goes wrong in the chain of things that are being used in that framework. And you do not want to frustrate your developers by running them with a pull request. So the next best opportunity is to run your test immediately after something is merged into the application code, right? And that's what this arrow denotes. The other mode is, which you can see with the thin arrow, is like to schedule your test like every few hours. And in this case, what you're saying is, well, we don't care when the code is merged into the application. Well, just run them at every 3 hours or every 4 hours or whatever. Many testers use this mode of execution, but I would not recommend this because, well, you are a little bit late in trying to find the bugs which could have been merged a few hours before. So that's what this arrow denotes. The third mode, and which is also my most preferred mode, is if you can run your test like on a new change on the application. So imagine a pull request is created on your application, and if you can run your stable test, like sort of doing a regression on those new tests before the code is merged into develop, you can actually prevent breaking changes from getting merged into an application. And this is where your automated tests have the most value, and especially for frameworks like when you're doing API testing. API tests are fast, they're more stable, there are less moving parts in between, and that is something that you can always schedule as a part of the CI pipeline, like as a build check. And if any of the test fails, your developers has to first fix those broken changes before they can merge their code into the develop branch. Now don't worry about like more details on this, because I am going to create more detailed videos which will explain in detail how all these three processes will set up in pipelines. So for now, it's just enough to know that we have three different use cases and we want to set test pipelines for all three of them. This is not like an and or situation. You really want to like set up test pipelines for all three of them, depending on if you're testing APIs, or if you're testing browser or application, or if you're just trying to check in new test code for your own test automation framework, right? So if that's clear, let's have a look and see how this process looks like in the local mode. So in the local mode, well, when a tester starts his day or her day, we want to create new tests, right? Or we want to like fix broken tests. And in this case, the trigger is, well, the human being. And what the person does is, the person just goes to the test automation repository, and we try to fetch the latest work from our cloud. Because maybe you're not the only tester who is working on this, maybe there are more guys who are working on it, and maybe one of the pull requests got merged, and the first thing that you want to do is pull the latest work on your local machine. Now, how does this look like in the remote CI part? So as you can see, once the tests are triggered, irrespective of what kind of CI solution that you use, if it is GitHub Actions, it is Jenkins, if it is Google Cloud Build or Circle CI or whatever, it does not matter. Like in principle, all these solutions work exactly the same. So the workflows that I'm showing you here, they will work for you irrespective of the CI solution that you use, irrespective of the programming language that you use, because in concept they will remain the same for any project. And like in remote also, we are doing exactly the same thing. So the first thing that we're doing is fetch the latest framework, right? And it does not matter if your cloud is like GitHub, Bitbucket or something else, is the same thing. If we come down in the localhost mode, like once we fetch the latest code, there could be multiple kind of frameworks on which you're working in. I gave some examples using some of my preferred open source tools, but again, you might be using a different tool. It does not matter, the process remains the same. So for example, for me, to test REST APIs, I like Rest Assured. To test browser applications, I like Selenium. To test mobile applications, I prefer Appium. For dependency management, I like to use Maven, and I like to use JUnit 5 as an assertion library. The reason why I like JUnit 5 is it's very neat, it's thread safe, you can run stuff in parallel very easily, and it provides you basically everything that you would need to write any sort of integration or system test. Many people get thrown by the word JUnit, like the unit in JUnit, and they think it's a tool to test, only do unit testing, but that's not true. You can do integration testing with it, you can do system testing with it, and in fact most of the libraries that are there, which are pretty famous, under the hood they are using JUnit or NUnit as their like assertion libraries. Okay, now let's go to the next step. What do we do next? So let's take an example. If you're working on the localhost machine, right, before you can run your test, you need an environment. Now you can either point your test to like the developed version which is available to in your company, or the staging version which is available in your company, or you can actually try to create a local version of the application on your own machine. So for example, if you're working with microservices, and if those microservices are Dockerized, which was the case at least in my last 3 projects, you can actually run all those microservices by running some Docker commands, right? You just do some Docker run, or you just do some Docker compose up, and then you can bring up the whole application on your local machine. If you want, you can actually also automate this process by using some PowerShell scripts or Bash scripts, depending on what kind of operating system you're using. I'm using Windows machine, and I like to automate like the whole process using a PowerShell script. But I can imagine if you're on Linux or Bash, maybe you might want to create a Bash script so that you don't keep running multiple Docker commands to spin up the whole infrastructure. Because typically, let's say if you have 8 or 10 microservices, rather than trying to run 8 or 10 Docker commands or Docker compose commands, you can just have one big script which can set up the whole application state for you, right? And like this box mentions, a typical use case is you are trying to create new tests on your test application, and you're trying to run it either on the stable branch, or let's say on the local host, like the stable branch, but created on a local machine. Let's see how this process looks into remote. So in remote, like depending on which mode you are using, so let's say if you look at these three modes, depending on which mode you're using, you either already have the application available to you. So for example, if you want to run your test on the stable version of your application, well, that's already available to you, right? So the environment is already available. You have to do nothing about it. In the second mode also, like when you are trying to run your stable test on the stable version of application, again, you have to do nothing about it. The application is already available there, and you just run your test with it, right? In the third case, when you are actually trying to run your stable test on the new changes for your application, that's the place where you would need help from your development team, or you would need help from your DevOps team. And actually, for that matter, like even in this case, if you want to run your latest test on the new code which is being deployed, like on your application, you might still need to take some help from your DevOps team or develop team, because like immediately after merge, the application will not be deployed, right? So there will be some time in between the application will deploy, and you want to first wait for the application to be deployed, and then you want to trigger those tests. And what it means is you need to modify the pipelines, so not in your test pipelines, but the pipelines of your application. And because you are touching the pipelines of your developers, you really need to involve them as a part of the process. So long story short, if you want to like run on this mode and this mode, you want to involve your developers and your DevOps, because you are trying to run your test on an upstream job which is in your application side, and it affects developers' job. If you want to run on this mode, then you don't need anything, and basically the environment is already available and you can directly run test, right? Let's move to the next part. So the environment is already built, right? And now you can run your test. Now the way you run your test on CI is you don't have a graphical user interface to click on things, right? So you typically run your stuff using command lines, and what you want to do is you want to pass the host environment from a command line, so that the right configuration can be picked for that particular test environment. So for example, if I want to run my test on develop or staging, I should pass that host environment variable as a part of my command line, so that the right configuration can be picked for it, and the right environment is picked, the right base URLs can be picked, the right database IDs can be picked, all that stuff. When we look in localhost, actually, even though you still have that mode available, you can run test from command line, but I typically don't do that much, because I'm trying to create new tests, or I'm trying to fix broken tests, and in which case running from IntelliJ is good enough for me, and that's what this thick arrow implies. Let's go to the next step. Right, so now when we have run our test, now we have different modes of running our test. Like you can see in CI, what we are trying to do is we are trying to like run our tests, right? We are trying to finish them as soon as possible. So actually we want our test classes to run in parallel, we want to run our tests in parallel. Basically we are trying to finish everything as quickly as possible. And maybe if I divert a little bit, let me show you this picture. So this picture comes from this URL from official JUnit documents, and what this says is that JUnit provides you 4 different modes of execution. An execution mode which is serial, in which case like every single test from every single test class runs in series. It then provides you a mode where you can run your test classes in parallel, but then the test runs in series. In the other mode, you can run your tests in parallel, but then the test classes will run in series. And then this is the fourth mode, in which you can actually run your tests in series, tests in parallel, and your test classes in parallel. And I love this mode, because like if you can increase your infrastructure, you can cut down your execution times by a lot. So it changes the problem of time into a problem of infrastructure and money, and that's why I prefer this mode of execution. This was in remote, we already saw this. So we are trying to run our test classes in parallel, tests in parallel. When it comes to localhost mode, even though you can do the same, like you can run your test classes in parallel, you can run your test cases in parallel, but if you remember, typically what we are trying to do in localhost is we are trying to create new tests. You are trying to like fix broken tests, right? And in which case our goal is to run them individually, and that's why even though these two modes are available, but you will typically not do them, and you are like building or running individual test cases, right? That's what this thick arrow means. Let's go to the next step. So once we have triggered our test, what happens is, depending on the host, just give me a minute, let me drink some water. Yes. So depending on the host that we picked here in this command, like what we passed, then we use a solution for configuration. TypeSafe is my preferred solution, but this is in Java. Now, depending on whatever programming language that you're using, you might have a different configuration solution. But in principle, what we're trying to do is, depending on the configuration that the host that we chose, we want to pick the right configuration so that our tests are running on the right host. So, for example, in remote, if I'm running my test on develop or staging, that particular configuration will be loaded on runtime. If I'm running on localhost, then the configuration for localhost is picked. So maybe the servers are like a localhost machine 127.0.0.1. In this case, you will have the servers for your develop or for your staging, right? Now let's go to the next step. So in this case, like till this case, you can see depending on which mode we are running, things are a little bit different. But once you have picked the configuration, we are going to run exactly the same test cases for all environments. It does not matter. So we're not going to have duplicate test cases. So it's not that, let's say, if you have 2 environments or 3 environments, you need to have like 3 set of test cases. Actually, if I remember my first project, we did not know how to do this right. So we were not able to run our test into different environments easily. But now, once I've learned about how to get this thing right, I don't have duplicate test cases, and now I'm able to run my same test cases for different test environments. And this is where JUnit comes into picture for assertions. Let's go to the next step. Now we're talking about test data. So when you're trying to run your test cases, right, you can do it in a couple of ways. You can either hard code your test data, in which case what will happen is, after a couple of runs, your test case will become a little bit less efficient. There's something called a pesticide effect, and what it means is, if you try to run the same set of tests with the same set of test data, then over a period of time, those tests becomes inefficient in finding new bugs. But let's say if you can randomize your test data, so imagine if you have an application which is supported in 4 countries, maybe Netherlands, Germany, France, and UK. Maybe you want to have data which is specific for those locales, because you can have different accents, different names, different characters which are used in different countries, and Faker is something that helps you with that. So it can generate random data for you, like names, addresses, phone numbers, with different accents and different data with different accents. And then if you use that in your test cases, you have a more variety of test data in your test cases, and there are more chances that you can find bugs which are more specific for data kind of things. And again, Faker is a specific library for Java. It does not matter if you're using a different programming language. Try to find a solution which is equivalent of that. Now, so once we're running a test, what you want to do is, and maybe I want to like elaborate a little bit on this part, because this is a very interesting part. Most of the testers, including me, what I was doing in my past projects was, when we're running our test, we publish our test results, right? And you see how many test cases passed, how many failed, how many are in error, and then you get some info out of it. And then the moment you do second run or third run, the previous runs have become sort of a history, right? And we are always looking at the snapshot which is in front of us. But what I have realized in the past is, if you can actually look at the trends, you can find a lot of meaningful information from trends. Let me try to give you an example. So imagine if you have 20 test classes, and out of those 20 test classes, maybe 10 test classes are always stable. They're always green, right? And maybe there are 5 test classes which are always flaky, and maybe 5 are always going into some sort of error. if you can like see a trend of this data in terms of pictorial graphs, in terms of like other trend graphs, you can actually see that, hey, maybe these 10 classes are always stable. So maybe the code is stable, maybe the application is stable for these modules, maybe my tests are stable, and maybe for the other parts where my tests are flaky or they're in error, maybe the application is going through a lot of changes, maybe there are bugs in those part of application, maybe my tests are not stable. So it gives you a lot of insight. Not only that, like imagine if you're triggering a test with pull request, even looking at the frequency in which, let's say, how many times you ran tests in the last month versus this month, you can see in which part in which part most of the action is happening. So this is something that only a test monitoring system can do for you. It can create real-time reports for you, but more importantly, it can create trends for you using historic information from months of data. And that's a very powerful tool. And now once I figured this out, like I cannot live without it. And again, this is common for both remote part and the localhost part. Now let's move on to the next part. Now once your tests are published, you can also publish the test results on the CI platform that you're running. So for example, if you're using Jenkins or if you're using any other platform, like the XML reports that are created by JUnit can be parsed by those platforms, and those CI platforms can also give you a build summary of how many test cases passed, how many failed, etc., etc. If you still want to create an HTML report, well, by using Maven Site, you can also do that. So this was like two different modes of creating reports in the CI form. Well, in the case of localhost machine, even though you can still like create HTML reports, you can still have XML reports, but those are possible, but most of the time we never do that, right? Like if you're running stuff in IntelliJ, you can already see the results like this, and then you're not interested to run these kind of things anymore. With this, let's go to the next topic. So the next topic is about, okay, now your test is finished. Now what? If you're running in the local machine, well, you know your test is finished because, well, you ran it and you can immediately see the results. But when stuff is happening in CI, you want to see how did it happen, because maybe a developer created a pull request and the test ran as a result. And you would not know that a developer has done that, right? So you want to get some sort of notification. And this is where an integration between your project and your Slack really shines. You can either notify results on Slack or you can get notifications on email. My personal experience is after a while, emails just become a noise and I don't want to use it. Like I really like the notifications on Slack. And not only that, typically Slack can provide you, it also gives you a URL on which you can click on the build result and it will take you to the actual build and you can see the results and analyze what went right, what went wrong. Now once this part is done, like all the automated part that we had seen so far, that comes to an end. Now you again need a human being to basically look at the results and see what does those results means. So typically when something is finished, either in CI, you get a notification, or you're running from localhost and now you want to look at the results. What is the first thing that you want to look in the results? So I think the first thing that you want to look at is if you had 100 tests, did all the 100 tests run or not? Because probably maybe only 70 ran because the environment was down, right? And if the environment was down, maybe a build failed, and in that case you want to go to your DevOps team and you want to ask them to create a new test environment. If you're running stuff from your local machine, maybe you can stop the containers, you can remove them, and you can create new containers yourself. So the first check is the completeness check. Did everything run? If the answer is yes, then you want to check for correctness, like are there any test failures? If no, well, that's good news. You can go on with your life. You can do whatever you are doing. But if there are any failures, then you want to analyze. You want to do a root cause analysis, and you want to see where does the failure lies. Does the failure lies in the app? Now, if that is the case, and how can you figure it out? So maybe you want to run those tests manually again on your system, and if you are able to replicate the same problems, then you know that, well, there is a failure in the app, in which case you can log a defect in Jira, and depending on the criticality, you can either add it to the sprint or you can add it to the backlog. But if the failure does not remains in the app, maybe you want to check if the failure exists in your test. And if that is the case, well, you want to fix your test, There are some cases where the failure does not either lie in the app and not just in the test, but it lies in both. Basically, the failure is due to the difference in test environments. I personally have experienced this. So for example, in one case, I was trying to assert the values from database, and I was trying to use like IDs, which were GUIDs, and of course the GUIDs will be different on local machine and on CI. So in this case, I knew that I have to basically update my SQL statements to use other criterias, which were common for both CI and in local machine. So in this case, I fixed my test. But then I also saw in one project that like the XPaths which I was using, or the CSS which I was using, they were different in localhost and in CI, in which case I said, hey, this is not cool. You want to have some sort of consistency. And then when I went to the developers, they actually fixed the application so that the same XPath and the same CSS were available in both localhost and on the remote machine. So with this, we have come to the end of this process. It took a little bit longer than I intended to. I thought it would be like a 20-25 minutes video. I can already see that it's like a little more than 31 minutes. But the idea is, now you have seen like how the whole end-to-end process looks like. And in the upcoming videos, then when we will start working on any of these areas, like if you're working on Slack or reporting or monitoring or Faker or like configuration, or like if you're talking about like running parallel capabilities, or if you're talking about building test environments, or if you're talking about frameworks, you will know exactly where they fit in. And when we will start working on the CI triggers, you will know exactly where they fall in the big end-to-end test automation process. So this like creates a big map in our brain. And now when we will start working on an area, it will help us understand, oh, I am already done with this part, now I'm learning about this part. So you know where you're going and you know what the end state is. Now in the next video, maybe what I will try to do is, now we have an artifact, right? And now I want to share this artifact with you. Currently it's only on my local machine. It's not version controlled. If somebody deletes it accidentally, well, I'm doomed. So what we want to do is we want to first create a project. So maybe in the next video I will cover that, and then I will try to version control it, which could be a video in itself. And then I will try to publish this project on a cloud platform like GitHub, and then it could be covered in another video. And then bit by bit in each video we will try to cover something like very specific about how to build production grade effective and efficient test automation frameworks. So I hope you found this video useful, and like I'm hoping that I can share more of my knowledge in my coming time. Like actually I tried to do this in the past a few months back, but time and priority has always been a little bit of issue with me. So I started it, I could not complete it. This time I'm really I'm really interested to do this. Like I'm finishing my job in one project, and now I'm picking my job in a few days, and in between I'm taking a 10 days of break. And the only reason I've taken this break is so that I can share my knowledge with you guys, and like give back to the community before I start with my next assignment. So if you like these videos, please subscribe to my channel. If you don't like it, well, that's also fine. But if you like it, then please come back again. I'm pretty sure I will have more awesome stuff for you to watch. So thank you for staying with me so far till the end of this video, and hopefully I'll see you again in another video. See you. Goodbye. Cheers. Bye-bye.